This is question 8 from paper 1 of the SQA Curriculum for Excellence Higher Specimen paper. We're given a couple of functions, f and g, in their formulae, and we're asked to work out h. That's g of f of x. So inside g goes f of x, which we know to be 1 minus a half x. So we really need to focus now on what g does to whatever goes into g. So in particular, the formula we're given, if x goes into g, we're told to square x, multiply it by 8, and subtract 3. So, for instance, if we put 4 inside g, then we would take 4 and square it, multiply the result by 8, and subtract 3. In fact, anything that goes inside g we would take that and square it, multiply the result by 8, and take away 3. So in this case, we're going to take 1 minus a half x, we're going to square it, multiply it by 8, and subtract 3. So let's write out 1 minus a half x squared in full, because we're going to have to use our firsts, outsides, insides last to multiply this out. So the first two terms, 1 times 1 is 1, outsides minus a half x, insides minus a half x. We've got a minus a half x and another minus a half x. We'll get minus 1x. Multiplying the last two, negative a half x times negative a half x. Negative times negative is positive. A half times a half of a half is a quarter. X times x is x squared. So a quarter x squared. And we subtract 3. So it's 8 times each of these three terms. 8 ones are 8, minus 8x, plus 8 lots of a quarter, x squared. 8 quarters are 2, 2x squared, minus 3. So we have 2x squared, right at the normal way round for a quadratic, 2x squared minus 8x plus 5. So now let's move on to part B. We're now asked to rewrite this expression we got, 2x squared minus 8x plus 5, in a special form. Well, let's see how close we can get that. Let's take out a factor of 2, not from the last constant term, but just from the first two. And keep in mind, let's just write this out, keep in mind the type of thing that we're trying to get. Having got to this stage, we certainly don't have something squared where we want two brackets identical. This number here would have to be the same, and we're going to have to get to minus 4x. So outside 2, inside 2 the same. Would that not be a minus 2 and a minus 2? Let's try that. If we multiply out x minus 2 times x minus 2, we get x squared. We get our minus 4x, minus 2x and another minus 2x, but we get a plus 4. So that's not quite right. However, it's very close to what we do want. If we have an x minus 2 squared, we've got this term, the x squared, we've got the minus 4x, but we've introduced a plus 4 that wasn't there. Let's just take it away. And remember, it's twice all of that. Maybe I should use larger brackets there just to emphasize that. So all I'm doing here is taking the x squared minus 4x, this part, and rewriting it as that. So that's all that's gone on there. So what have we got left? We really have to multiply out by 2. So 2 lots of this x minus 2 all squared minus 2 lots of the 4. 5 doesn't come under this 2 times business. It's outside the big square brackets, so it's not multiplied by 2. So we're getting close. 2 lots of x minus 2 squared minus 8 plus 5. Remember, if you're in the number line, minus 8, add 5, and you'll end up at minus 3. So if we just compare it, we don't need to do this, we can just visually check it, but if we look at the form we were asked to write it as, we certainly got an a being a 2, this plus p is minus 2, and this q would be a negative 3 plus negative 3. So we've done it. We've got that in the form that we wanted it. So let me just put that, a copy of this, because we'll need that for the next part. Let me put a copy of that up here. And we can now get rid of everything else and have a look at part C. Hence or otherwise state the coordinates of the turning point of the graph of y equals h of x, which is this, which we now rearranged to get that. So the turning point in this graph is where this becomes a minimum value. Look at the fact that we've got twice something squared minus 3. And let's concentrate on squaring numbers. Nothing squared is nothing, 1 squared is 1, 2 squared is 4, minus 1 squared is positive 1, minus 2 squared is positive 4. When you square numbers, you get the typical values. If you graph them, you get the typical shape of a parabola, with the minimum point, the turning point, occurring when you square 0. So if we have this x minus 2 being 0, which would occur when x is 2, when x is 2, this reaches minimum. So when x equals 2, y is equal to twice 0 squared minus 3. That's the least it can ever get. So 2 times 0 is 0, minus 3 gives us minus 3. So the turning point on the graph, y equals 2 lots of x minus 2 all squared minus 3, is 2 minus 3. When x is 2, it reaches a minimum value of minus 3. So that's the turning point. Now the last part of the question says sketch the graph of this y equals 2 lots of x squared, 2 lots of x minus 2 all squared minus 3 plus 3, showing clearly the coordinates of the turning point and the y-axis intercept. So let's do that. So we're now on to part C, where it asks us to find the coordinates of the turning point of the graph of y equals h of x. So the various stages we've been through, we first of all showed that h of x was equal to this quadratic. We then rewrote it in a special form where we had something squared in the term. So using this last term, and let's look at quadratic graphs. We know quadratic graphs make parabolas. Turning point be a minimum here, a maximum here. And because x squared has a positive number in front of it, we know that this is the form of the quadratic. This upside down one, or concave downwards as it's called. This is concave upwards. A concave downward one would have a negative coefficient for x squared, negative number in front of the x squared term. So we're in a concave upwards with a minimum stationary point or minimum turning point on this graph. So we're basically trying to find when this expression reaches its minimum. Now, if we think about squaring numbers, let's take the basic case of, say, squaring 0 gives us 0, squaring 1 gives us 1, squaring 2 gives us 4. If we square negative 1, we again get positive 1. Negative 2 times negative 2 is positive 4. There's our typical parabola with minimum value occurring when we square 0. So if we look at when this term, x minus 2, when is x minus 2 equal to 0? Well, that happens when x equals 2. So if I put x equals 2 in place of, well, if I make x have a value of 2, inside the squared term I get a 0. 0 squared is 0. We get twice 0 minus 3, which is just minus 3. So I know that this graph comes to a minimum value of negative 3 when x is 2. So that's got me my minimum turning point. It's 2, negative 3. And finally then, part D, we have to sketch the graph of y equals h of x plus 3. So we're looking at the graph 2 lots of x minus 2 squared minus 3 plus 3. Remember, this part of it was what we'd found h of x to be. Well, negative 3 plus 3 is 0, so we're looking at a graph twice x minus 2 all squared. And we're wanting to sketch that graph. Now, from our previous discussion, we know this again will be a parabola, and again it'll come down to a minimum value when x equals 2. 2 minus 2 is 0 squared. And in this case we'll get a minimum value of 0, 2 lots of 2 times 0 squared. So we know this comes down to a minimum value of 0 when x equals 2. So we have a parabola coming down to its minimum turning point at 2, 0. Where does it cross the y-axis? We have to work out when x equals 0 what the y value is. And that would be twice 0 minus 2 squared. Well, 0 minus 2 is negative 2. Negative 2 times negative 2 is positive 4. 2 4s are 8. So it crosses the y-axis at the point 0, 8. So I'm beginning to see the shape of this graph. It has a symmetry about the line x equals 2. Let's just sketch it in there and check that we've answered the question. There's the origin there. Sketch that graph showing clearly the coordinates of the turning point and the y-axis intercept. Well, that's possibly, we could quibble that that's not coordinates. We would have had 2, 0 as coordinates. So there's the minimum turning point, 2, 0, and the y-axis intercept, the value that y takes when it crosses the y-axis is 8. So there's our sketch.